In 1822, researchers walked into a banqueting hall at Malbork Castle in Poland. The hall stretched 850 square meters, ceilings 3 stories high. It had been sitting at 6 degrees Celsius all winter. They lit a fire beneath a chamber of granite boulders buried under the floor. They fed it wood for 3.5 hours. 20 minutes later, the hall hit 22.5 degrees. The system was 4 centuries old. It still worked. The material that made it possible cost $16 per cubic meter. The lithium battery your energy company wants you to buy instead costs $39,600 per cubic meter for the same function. That is a 2,500 to 1 ratio in raw material cost. No UL listing exists for any residential version of this technology. No building code in 49 states provides a pathway. No appraisal system will value it. This is not ancient history. This is a story about a technology too cheap to be allowed. The solution was not invented once. It was invented independently by every civilization that ever had to survive a winter. Korea, approximately 1000 BCE. The An-Joel. An external furnace burned fuel outside the living space. Hot gases moved through channels cut beneath thick stone floor slabs. The thermal mass absorbed the heat and released it slowly over 12 to 24 hours. The fire could die. The floor stayed warm. By the 15th century, it was standard construction across the entire peninsula. Not a luxury. How you survived a Korean winter. Today, over 90% of South Korean homes still use a direct descendant of that system, China. The Kang. A heated sleeping platform connected to a cooking stove by a flue system. As recently as 2004, 67 million Kangs served 175 million people across 14 northern provinces. Not history. Present tense. Heating loads reduced by 50 to 80%. Rome engineered the same principle into the hypocaust. Raised floors, hot air channels, stone mass doing the work. Finland never forgot it. Tuulikivi Corporation, founded 1980 after the oil crisis. Soapstone masonry heaters, 5 to 7 tons, 1 30-minute burn, 24 hours of heat. No electricity, no moving parts. 300,000 homes worldwide. Every civilization with access to stone arrived at the same answer independently. The reason every civilization arrived at the same answer is because the physics is not complicated. It is just not profitable. Thermal mass absorbs heat, holds it, releases it slowly. The denser the material, the longer the cycle. Sand is dense, abundant, and chemically inert. It does not react, it does not degrade, it just stores. The National Renewable Energy Laboratory tested it. They heated silica sand to 1,200 degrees Celsius and held it there for 500 hours. Then they measured every property they could think of. No significant changes in any measured parameter. No degradation, no chemical change, no wear. The technology does not age because there is nothing in it that can age. Here is the counterintuitive finding. Polar Energy's lead scientist demonstrated that heat applied to one side of a 1-meter block of sand at 500 degrees Celsius takes over 8 days to reach the far side. 8 days. 1 meter. The sand insulates itself. The same property that makes heat difficult to extract quickly is what allows sand to hold it for weeks without significant loss. Now the number that should stop you. Sand stores energy at $4 to $10 per kilowatt hour. A lithium-ion battery stores it at $300. Not a small difference. 30 times more expensive. A 2,500 to 1 ratio in raw material cost. Same function. You do not need a factory. You do not need a contractor. You do not need a permit. A 55-gallon steel drum. Mineral wool insulation rated to 1,000 degrees Celsius. A heating element from a hardware store. A high-limit thermostat. Total materials under $300. One builder on a homesteader forum wired 4 260-watt solar panels directly to heating coils embedded in sand. No inverter, no battery, no grid connection, no monthly bill. Just photons hitting silicon, electrons flowing through wire, and heat entering sand. His test vessel hit over 1,000 degrees Fahrenheit. A forum member scaled the same principle to a 55-gallon drum. Yesterday, my sand battery hit over 600 degrees. This morning, the lowest temperature was 234, under $300, held overnight. At commercial scale, the numbers become harder to ignore. Polar Energy's Kanka on Pa installation. 100 tons of ordinary builder sand. 8 megawatt-hours of storage. District heating for approximately 100 homes plus a public swimming pool. Their Pornainen installation, 2,000 tons of crushed soapstone, 100 megawatt-hours, $25 per kilowatt-hour of storage capacity, 1/4 the price of lithium ion, 160 tons of carbon dioxide eliminated per year. One honest number. Round-trip electricity to electricity efficiency runs 50% to 52%. But a home does not need electricity back. It needs heat. In thermal terms, the round-trip efficiency runs 75% to 90%. The physics works. The cost works. Material is already in every hardware store on your street. So why has no American ever installed one legally? The answer is not a conspiracy. It is a system. The International Residential Code governs what you can legally build in 49 states. It prescribes specific materials and methods: concrete, dimensional lumber, masonry, light gauge steel. Everything outside that list must pass through a variance process. A registered professional engineer analyzes your system, costing $2,000 to $10,000. Then third-party testing by UL or an equivalent body, costing $10,000 to $50,000 or more. Then approval from a building official who has likely never seen the technology you are proposing. No UL listing exists for any residential sand battery. No UL listing exists for any solid thermal storage heating device. No category. No pathway. The organization that writes American heating standards published a design guide in 2019 that explicitly excludes hot storage and passive thermal systems. The gap is not accidental. It is structural. Then the appraisal system. Fannie Mae and FHA require a functioning heating system for mortgage approval. One documented case. A homeowner installed a $15,000 solar and storage system. The appraiser valued it at $0. Then, insurance. No UL sticker on the drum. A fire claim can void your entire policy. No villain required. A system designed to certify manufactured products automatically excludes anything built from commodity materials on a job site. Behind the system, there is an organization. The American Gas Association represents gas utilities across the United States. It maintains a Building Energy Codes and Standards Committee. It recruits members to bolster voting power at the International Code Council, the body that writes the IRC adopted by 49 states. It coordinates testimony. It proposes code language. It organizes opposition to electrification provisions. In 2018, a GTI employee wrote in an internal communication, "Massive force switching to electric technologies under decarbonization policies is an existential threat to natural gas direct use in buildings." Existential threat. Their words, not mine. As of 2024, the AGA had helped pass preemption laws in 25 states preventing cities from banning natural gas in new construction. They reversed Berkeley, California's first-in-nation gas ban through federal court. The residential heating equipment market exceeds $12 billion annually. The top 8 HVAC vendors control approximately 90% of revenue. The business model is proprietary equipment, licensed installation, periodic service, eventual replacement. Emergency replacements alone account for 60% of residential HVAC sales. A heating system with no moving parts, using commodity sand that never breaks, never needs service, and cannot be metered is not compatible with this model. They update the building code every 3 years with committees that include HVAC contractors and equipment manufacturers. They have built an appraisal structure that values a gas furnace at market rate and a sand battery at zero. A heating system you cannot meter is a threat to every business built on metering. Same physics, same sand, different government. Business Finland funded both the Kankaanpää and Pornainen installations. Finland's Minister of Economic Affairs attended the Kankaanpää inauguration in person. The project was named Finland's Productive Idea of 2023. It appeared on NASDAQ Helsinki billboards. It appeared in Times Square. Founders were 2 engineers at Tampere University who started their first prototype in a grandparent's backyard cottage. By April 2024, they had raised 7.6 million euros in seed funding. Time named their sand battery one of the best inventions of 2025. 0 installations in the United States. The question the contrast forces is simple. It is not whether the technology works. It is whether anyone with the power to allow it will. $16 per cubic meter. $39,600 per cubic meter. Same function. 2,500 to 1. The sand is already here, under every driveway, in every bag, at every hardware store on your street. It heated Korea for 3,000 years. It heated a medieval banqueting hall in 20 minutes. It is heating 100 Finnish homes right now. The building code has no category for it. The appraisal system cannot see it. The insurance forms do not acknowledge it. It does not break. It cannot be patented. It asks for no subscription, no service contract, no recurring bill. There is a wall that generates heat from sunlight alone. Invented in 1967. Still not in the building code. That story is next.